Hey everyone, welcome to your introductory video on probability. In this video, all we're going to do is kind of describe the basic definitions of probability and set up some really basic notation for you. It's kind of an interesting lecture, and then what we'll do is some very simple examples at the end, and then in your next couple videos, what you'll do is you'll look at some more difficult examples. Alright, so what you should do is you should download the PDF file that comes with this lecture, and as I go through the lecture you'll see me typing in some things and adding to the PowerPoint. What you should do is you should copy that down into your notes so you could have a better understanding of what's going on. Okay, so let's start with some definitions. So the first thing is an experiment. Alright, so in probability what we're going to do is we're going to perform some type of an experiment. Alright, and all this is, alright, the definition is this is an act or process. Alright, so it's something that you do that leads to a single outcome, so there's only one thing that can happen. Alright, now this is important. That outcome that you get cannot be predicted with certainty. So maybe I know what could happen, but I don't know for sure what I'm going to get. Alright, and the last part is as soon as you perform the experiment, you can do it again. It could be repeated. Alright, so let me give you some examples of some experiments in probability. The easiest one we'll talk about a little bit is, flipping a coin. I could get heads or tails, but I don't know for sure what I'm going to get. The next one would be rolling a die. Right? In this class we'll talk about a six-sided dice. When I roll a die I could get the numbers 1, 2, 3, 4, 5, or 6, but I don't know for sure what I'm going to get. The last one would be something like drawing a card from a deck of cards. Alright, if I draw like a ace, king, queen, 2, 5, 10, whatever, I don't know what I'm going to get, but I can put the card back and I can repeat it. Alright, so right off the bat, we're going to perform some type of experiment. Alright, the next two definitions. If I'm going to perform an experiment, that would be a set or list. Alright, the sample space, would be a set or list of all the possible outcomes for some type of experiment. Alright, and we denote that sample space for an experiment with the letter S. Alright, so let me give you two examples. If you toss a coin, the sample space for that, well, that could be heads or it could be tails, because those are the two possible outcomes for a coin. Now if you roll a die, the sample space for that could be the numbers 1, 2, 3, 4, 5, or 6. Right? We use these curly bracers here. They look like this because it's a set, so we use set notation and we just list all the possible things that could happen. Alright, so we're going to perform an experiment, alright, and we're going to be interested in the sample space. Alright. If we perform an experiment, we know all the possible outcomes. What we're primarily going to be looking to derive the probability for are specific events happening. Alright, so an event, alright, that's any subset of a sample space S, and is typically denoted with a letter, so A, B, C. But generally for events, I'm going to use the letter E, E for events. Alright, so for example, if I toss heads, well, the list of possible outcomes for heads, well, there's only one. Right? That's just heads. If you roll an even number on a six-sided die, right? Well, the possible outcomes for an even number would be the numbers 2, 4, or 6. Alright, so a sample space is all the possible outcomes, but the event list, well, that's just the subset of what I'm interested in, like just the heads or just an even number. Alright, let me give you some rules of probability. Alright, so the notation for this, alright, if we want to perform probability. So we denote the probability of an event occurs as the following. So if I'm interested in finding the probability I flip heads, I would write it like this, P for probability. And then I would put what I'm interested in parentheses inside. Alright? So I would read this as the probability of heads. Alright? Or if I'm interested in rolling even, I'd say the probability of an even. Right? So that would be read the probability of an even number coming up when I roll a die. Alright, so P and then in parentheses what you're looking for. Alright, so a few quick questions. Can you ever have negative probability? No, you cannot. You can't say the probability that something occurs is negative 20%. Just doesn't make sense. All right, can you have anything be more than 100% chance of occurring? Well, that would also be no. You can't, if you load up your iPhone weather app, it'll never say that the probability or chance of rain tomorrow is 120%. That doesn't make sense. All right, so probabilities are always between 0 and 1. All right, 1 being 100%. Right, that's just probabilities will generally be shown, as a fraction or a decimal between 0 and 1. 0 being the lowest, impossible to happen, 1 being the highest, 100%. All right, so I want to give you guys the classical definition for computing probabilities on the next slide. All right, so when you want to compute probabilities, it's just a very, very basic fraction. All right, and we'll actually show you the probability with an example. All right, so the example will be, well, let's roll a die once. We're going to roll a 6-sided dice once. All right, so we know what the sample space is. All right, that's all the possible outcomes. So when I roll a die, possible outcomes are the numbers 1, 2, 3, 4, 5, 6. So if I'm interested in the probability of a specific event E, so I would denote it this way. Probability, and then in parentheses E, what I'm interested in. Now it's just a fraction. The numerator is just the number of ways that E can occur. Right? So whatever the event E is, well, how many times could that happen? And I'm going to divide that by the number of possibilities, or the number of total outcomes. All right, so here will be the question we'll ask ourselves. What is the probability you will roll an even number? All right, so over down here, I'm going to put my probability statement, probability, even number. Well, the numerator of the fraction is the number of ways E can occur. Well, there are 3 ways that you can roll an even number. That would be 2, 4, 6. That would go right here. And I'm going to divide that by the total number of possibilities. Well, there are 6 different numbers on the die. So the probability to roll an even number would be 3 out of 6, which would simplify to 1/2. Or you could write that as 0.5. So that's it. That's a very simple way how you compute probabilities. Just the number of ways it could happen divided by the total number of possibilities. All right, let's just do 2 quick word problems. So 2 more examples that'll help us. All right, so here's a kind of a silly example, but suppose this person, Lawrence, is the captain of his track team, and he wants to pick the color for his team. All right, so the team is deciding on a color, and all 8 members of his team wrote down their choice on equal-sized cards. So if you look down here, here are the 8 cards they filled out, and on the card they put the color they wanted their team to be. So blue, yellow, red, green, blue, blue, black, or black. All right, so if Lawrence picks a card at random, what is the probability he will pick blue? Well, if you look here, there are 1, 2, 3 blue cards, or yep, 3 blue cards with that the team wrote on. The total number of cards, 1, 2, 3, 4, 5, 6. There's 8 of them. So I would write it like this: the probability that he picks blue. Well, that's just the number of blue cards in the pile, 3, divided by the total, and that just simplifies, if you put that in your calculator, to 0.375. That's the probability that he would select blue out of all the colors. All right, let's do just another quick one. All right, suppose this individual, Donald, is rolling a number cube, so that would just be a die, another way of saying it, with the numbers 1 to 6 on it. What is the probability of the following? That he rolls an odd number. All right, so my event E that I'm interested in is that he rolls an odd number on a die. Well, that would be the numbers 1, 3, or 5. Well, the sample space for this outcome? Well, on a die you get 1, 2, 3, 4, excuse me for that mistype, 3, 4, 5, or 6. So then the probability that he rolls an odd? Well, if you look in my event list, there are 3 possible ways that could happen. If you look in the sample space, there are 6 possible ways. Well, that simplifies to 1/2, or you could write it as a decimal, 0.50. All right, let's look at this one. Let's calculate the probability that he gets a number greater than 5. All right, well, my event list. On a 6-sided dice, what numbers are greater than 5? Well, just the number 6. The sample space, again, is 1, 2, 3, 4, 5, or 6. So the probability that he rolls a number, probability greater than 5. Well, there's only one way that could happen. A person could roll a 6, and there are 6 possible outcomes. So if you plug that in your calculator, it's 0.166. It keeps repeating, but we'll leave it just like that. All right, so hopefully, don't get too bogged down in the terminology here. All right, event, sample space, things like that. What's most important is this definition here. All right, the probability that something happens, well, it's the number of ways it could happen divided by the total number of possibilities. All right, so there's going to be another video where we're going to work some more complicated examples. All right, I encourage you to watch that and download the lecture slides that go with it. All right.